Hello again. Thanks for joining us on a new episode of Space Nuts. My name is Andrew Dunkley, your host, and it's good to have your company. And coming up on this episode, we've got some fascinating stories as always. And one is about a possible swarm of black holes that might have been discovered in a rather well-known region of space too, I might add. They thought there was one. Now they think there might be 20,000. I'm not exaggerating. We're also going to look at the Polaris Dawn Mission. Now, by the time this podcast is released, it may well have happened, but it might not. Just depends on technical issues. They're sitting on the platform at the moment playing Scrabble, waiting for things to get fixed and the PUFU valves to be unvalved and all that sort of thing. We'll also look at the New Horizons mission. It's 18 years along now and 9 years since it did its flyby of Pluto, but it's still working. What's it working on? Darkness. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us again to unravel all of that and much, much more is Professor Fred Watson. Hello, Fred.
Hello, Andrew. Unraveling is our business.
It is.
We're pretty good at raveling as well, especially when it comes to things like headphone leads and things of that sort.
Yes, I've got one of those stretchy ones.
There you go.
And it does a good job, except it keeps getting in the wrong place and it's a bit annoying. But I can't go wireless. You can't go Bluetooth through this panel I've got because of the time delay, just to make things difficult. So you'll talk to me and I won't hear it for a second and a half, which is not,
that
not
probably means
ideal.
it might be going via the moon.
Could be.
From your desktop to your headphones via the moon. That would be more like two and a half seconds.
Yeah.
1.5 seconds.
Well, when I bought them, it said if you choose to go Bluetooth, you may discover that it doesn't work the way you want it to, and that's exactly what happened.
That's interesting.
Yeah. So it's not all bells and whistles, not all perfect. Tell you what else isn't perfect. The weather's been perfect lately, but so's the hay fever. It's ripping through us at the moment. My word.
Yeah. Yep.
I'm a terrible sufferer, and I thought it was just because of where we lived. So when we went to England many years ago and got off the plane, I wasn't even off the gangway or the sky bridge or whatever you call it, and I was sneezing. I thought, oh, no. I thought I escaped all this by coming to the exact opposite side of the planet, but no, it just got me. So now I know it doesn't matter where I am. I'm going to get hay fever if there's pollen in the air.
Quite so.
I'd like someone to do a study on why it develops later in life, because I never had it as a kid.
No, I didn't. I didn't either. Neither did Geordie, as you probably just heard there.
He loves to contribute, does Geordie?
Yes, he does. Same thing happened to me. But mine was a bit more obvious because I grew up in the north of England and studied in Scotland and kind of hung around the north of England for the first 20-odd years of my life, and then moved to the south, which is verdant and green and grassy, and immediately got terrible hay fever.
Yeah.
Which I now know is an allergy to ryegrass.
It will be for me too. There's a lot of ryegrass out here.
Yeah.
So I haven't had it. I haven't been tested, but I'm making that assumption. Also allergic to cats.
There you go.
Grew up with a cat, never had a problem. Now I can't. I can no longer rub my face in their fur, which is so disappointing. So disappointing.
Yeah. If you tried rubbing your face in Muscat's fur, he'd take your eyes out.
Yes, that's the other problem. That is the other problem. That may explain the itch.
Yes, yes, that's right.
Now, let's get down to business. This story is interesting because it really changes the way we're looking at one particular piece of space, and it's an area where we thought there was an intermediate mass black hole, was it? Now they think it's not. It's not a black hole. It's a multi-faceted number of black holes in possibly the tens of thousands. This is quite extraordinary.
It is. It's a story that, we've been following the intermediate mass black hole story for quite some time. And just to fill in the details for anybody new to the issue, we commonly find what we call stellar mass black holes with a mass of, up to 20 stars, up to 20 suns. And we commonly find supermassive black holes, which are sometimes 20 billion times the mass of the sun. But there doesn't seem to be anything in between. The intermediate mass black holes have been elusive. And one place we think we might find them is in the center of these really spectacular, gigantic star clusters that we call globular clusters, because they're globular in shape. That name was given to them by William Herschel a couple of hundred years ago or more. We have, by we I mean the world of astronomy, has basically been hunting for intermediate black holes in the centers of some globular clusters, and with sort of varying degrees of success, in the sense that some of these findings are more certain than others. But one that we covered recently was a finding that we were pretty sure about for a while. And that is the globular cluster Omega Centauri. It's the biggest of our Milky Way galaxy's retinue of globular clusters, 160 or 200 of them, and this one is the biggest of them. Distance of 17,000 light years as the crow flies, in the constellation of Centaurus, which is why it's called Omega Centauri, and visible just about to the naked eye. In fact, it's this time of the year where we start seeing it quite well from here in the southern hemisphere. It's a deep south object, only visible from the southern hemisphere. So, what's the story? Well, scientists, in fact, European scientists who were using, I think, something like 20 years worth of images from the Hubble Space Telescope, which allowed them to plot the motions of stars within Omega Centauri. And in particular, they let them map the motions of stars near its center, which seem to have quite high velocities and which are symptomatic of something massive around which they're orbiting. So you've got stars with high velocities. In particular, the kind of velocities that were being talked about, and I think they're in the region of 3, 4, 5, 6 kilometers per second, thereabouts, if I remember rightly. Those velocities, if there wasn't something massive at the middle, will be enough to catapult them out of the globular cluster, and they'd be long gone. There'd be interstellar, stars, if I can put it that way, stars between the stars, but more they will be within the halo of our galaxy, which is where the globular clusters lie. The halo being that sort of spherical shell of old stars and globular clusters. So that was the story as we reported it. The evidence that there's possibly something like a 20,000 solar mass black hole at the middle of Omega Centauri, and we were really excited by that, because I think we'd only just sort of concluded that there aren't any, and then we found one. Yes, that's right. And then now we haven't. We've unfound it. Because another group of scientists using similar data, I think they've basically analyzed the same data set, have suggested that the motions of the stars do not tie down that central mass as being a single object. What they're saying is that it's like it could equally, and that's perhaps the best way to phrase it, it could equally be a large cluster of much smaller objects. They're still black holes because you can't see anything of them. There's nothing massive visible there in any of the wavelengths. But we can tell by the motions of the stars that there is something there. And so what they are suggesting is that it's not a single intermediate mass black hole. It's not that. It is more likely, or as likely, if I can put it that way, to be something between 10 or 20,000 stellar mass black holes. In other words, the smaller variety.
Right.
And that's the bottom line. And the group that's suggesting this, one of the team members, Francesca Calori from the French National Centre for Scientific Research, says the possibility of an intermediate mass black hole in Omega Centauri still exists. Our analysis does not rule out an intermediate mass black hole, but rather sets a limit on its mass, predicting an upper limit of 6,000 solar masses, which is less than what the earlier team estimated. And so they're trying to work out what that discrepancy is. But yes, the later paper, the new research, Calori et al., is saying it might not be a single object. It could be, lots of smaller objects.
Yeah. And that's been backed up by another gentleman at Leiden Observatory, I think, who agrees, even though he wasn't part of the study, agrees it's probably a multitude of stellar mass black holes rather than an intermediate mass black hole.
Yeah,
so
that's correct. And there's an old friend of mine who was also commenting on this, Jerry Gilmore, who I've known now for 40 years.
Yeah.
He's a very big name in the University of Cambridge. He's a Kiwi, actually. Came to the UK to work at the Royal Observatory in Edinburgh, where I was working. We became good friends and still are. Jerry he wasn't involved with the study either. And he thinks that stellar mass black holes are likely to be common in comparison with intermediate mass black holes. So I think he's favouring the latest research, the idea that this is perhaps a whole lot of smaller black holes rather than one big one. And as you say, there's comments from Leiden Observatory, Simon Portegies-Zwart, if I'm pronouncing that right.
You did better than I would
have. Finds the potential discovery of an intermediate mass black hole super exciting, but suggests that the evidence isn't quite there yet. So I think the opinion of the astronomical community is let's wait and see what future measurements bring out. It doesn't look as though we've nailed down the Omega Centauri intermediate mass black hole yet, and it may not be there at all.
That said, though, how unusual is it to find between 10 and 20,000 stellar mass black holes in a globular cluster?
Yeah, that in itself I think is interesting. If you could independently verify that these are singular objects rather than one big object, I think you have another new discovery on your hands. So what you're talking about here is going to be the remnants of dead stars. What you're talking about with an intermediate mass black hole is the remnant of what might have become a supermassive black hole if that globular cluster had not been torn to shreds by getting mixed up with our Milky Way galaxy, the gravitational pull. Because we think that globular clusters are the central nucleus of galaxies that have been basically demolished by gravitational interaction with our own. So that's why people are looking for intermediate mass black holes inside globular clusters, because the thinking is if you've got something that under normal circumstances would eventually grow into a supermassive black hole by the time the universe is 13.8 billion years old, which is its current age. If you have that structure, but then you stop the evolution process because you tear the galaxy to pieces because it interacts, it gets basically sucked into the Milky Way galaxy. What you're going to be left is something, it's like a wannabe supermassive black hole, which is why it's a good place to look for intermediate mass black holes, ones that didn't quite make it.
So if it turns out it's not an intermediate mass black hole, does that mean we still haven't found any, or were there other candidates?
There are other candidates, as I recall. I wouldn't like to pin down without looking them up as to what they are, but there are other candidates. So it isn't just this one, but this one, Omega Centauri is the biggest and most spectacular globular cluster in the sky. As I said, it's visible to the naked eye. It looks terrific. Even with a pair of binoculars, it looks good. You can tell it's something different from the stars around it. through a larger telescope, it looks sensational because you can see all the individual stars resolved in it.
This creates a new problem, Fred.
What's that?
Well, if it is stellar mass black holes they've found, and there are 10 to 20,000 of them, which is what they're suggesting, the world will have to come up with a collective noun for black holes because there isn't one.
It will. Ah, right.
There isn't one.
Surprised at that.
Yeah, I was too, but I found a couple of articles which state no, there isn't. There's a collective noun for asteroids. It's a belt of asteroids, which, yeah, it's a good one.
Yeah.
But there is no collective noun that I'm aware of for black holes.
Maybe a space knot of black holes would be
I like
really
that.
good one.
Yeah. I was going to say a nothingness.
Yes. Trouble is there isn't.
There isn't nothingness.
No, there isn't.
Yeah, it's a little bit of a problem, but it's not the biggest problem we'll face. But I was surprised there wasn't one.
Yeah, me too.
Yeah.
I'm surprised also.
Anyway, the jury's still out. Could be one, could be the others. We're not sure
Right.
yet. We're not sure yet. But if you want to read up on that, it's a great article in skyandtelescope.org. This is Space Nuts. Andrew Dunkley with Professor Fred Watson.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
Now, Fred, to the Polaris Dawn Mission. And this is a very exciting mission. It may well have lifted off since the release of this particular podcast, because we're working a bit ahead at the moment, because I've got to take a trip and we need to get a whole bunch of episodes in the can, so they say. Yes, this particular mission may well have lifted up. At the moment, as we speak, they have some technical issues and they're stuck on the ground and they're all getting pretty tired of Scrabble. But
Could be Monopoly.
Could be Monopoly, could just be Uno, who knows?
Or drafts.
Yes. Oh, gosh, now you're getting desperate. But this is an exciting mission for several reasons. There'll be some major firsts that will be achieved. They're doing things a little bit differently, and they're planning a spacewalk, which will be the first private spacewalk, I believe, privately conducted. There's so much that's exciting about this mission, Fred.
Yeah, there is. You're right. It's partly technical issues, partly the weather, in fact, that's been holding them up.
Yeah,
as
the
things
splashdown
stand at the
weather.
moment.
So
Yes, exactly.
yeah, it's not so much about getting off, but getting back on the planet.
Indeed. What's exciting about it? Well, it is going to be. It may even be the first crewed mission that is going into a polar orbit around the Earth.
Wow.
I think that is correct. So it's an orbital direction that hasn't been explored before with crewed space launches. It's also not going anywhere. It is not going to the International Space Station, as you wouldn't be able to if you were in a polar orbit, because you need an orbit very similar to the International Space Station if that's where you're going.
Yeah.
That means that the time that the crew will be on board, and I'm actually not sure how long it is planned to be, but they're going to be in the spacecraft for the whole time, except when they make the first privately operated extravehicular activity. And because what they have to do then is climb out of their SpaceX Crew Dragon capsule. Two of the members of the crew, there'll be 4 people in the crew of Polaris Dawn, 2 of each gender, and 2 of them will climb out of the capsule for the first private space walk. And what that means is you've got to let space into your capsule.
Yes.
You've got to vent all the air out of it. So everybody has to wear their spacesuits.
Super scary.
It is,
Super
isn't it?
scary.
Opening the front door.
Because they have airlocks in other spacecraft and the International Space Station.
Yep, that's
But
correct.
this one, you open the lid and you're in space before you even get out.
Yes, that's right.
Well,
So
you've got to vent, haven't you? And then you
yes, they
become
will vent it
space.
first, and then I mean, I'm sure there will be a very, it would be a pretty careful venting just to make sure everything's holding together before you let all the air out.
Yeah, it's not like cleaning the fish tank, that's for sure.
That's right. Although if you find fish floating around in it, you might be. Anyway, it's yes. So it really is interesting, and the fact that they're not visiting the space station or going anywhere near it means they have to be pretty secure in their plans for this mission, because all the supplies for the crew, food, water, oxygen, everything, that all has to ride with them in their Crew Dragon capsule. And so it's a very, very demanding, a highly demanding scenario. It's 5 days, the mission, just to add to what I was saying.
I just looked it up myself.
Yeah. And the other thing that they'll do is they'll go further from Earth than any human since Apollo 17 back in 1972, because their orbit is very elliptical. It's an elongated orbit, which will be close to Earth at its perigee, the closest point, but a long way off at apogee. I am not sure what the target apogee is, but it is more than we've ever done before in terms of a mission of this kind. So what's holding it up? Well, as I mentioned earlier, the weather, and as you said, yes, it's the weather at the landing site, but also the fact that within the last 48 hours, certainly, if not 24 hours as we are recording, Falcon 9 has been grounded. The Falcon 9 launch vehicle that they will use has been grounded by the Federal Aviation Authority due to a failed booster landing attempt, I think on Wednesday this past week. So it's this is basically a risk minimization procedure. As soon as anything goes wrong, that booster, the Falcon 9, the whole Falcon 9 fleet is grounded until you know what the problem was.
Yeah.
One of the interesting things, I think I read a little while ago, that booster that failed, I think it was its 23rd mission. So it had been used 23 times. Now, originally they said they'd only reuse them 10 times. Then it went to 20 times. I suspect now it's aimed at 30 times, but maybe 23 is as far as it goes.
Yeah, we'll stop at 15 just to be safe by the sound of it.
That's right. Yeah, certainly if it was a human space flight, I think you would want to make sure that you were using a pretty new booster rocket to get you up there.
Indeed. And I believe they'll be doing about 40 experiments. You might have already said that, which will test everything from human space flight research to microgravity. And they'll be using brand new spacesuits to do the spacewalk and I guess they'll be testing those, and let's hope they go, oh, hang on, this thing doesn't work.
Before they invent the spacecraft.
I'll be taking that back to Lowe's.
Yeah.
Sorry, for your overseas listeners, that's a menswear store. So that, it automatically becomes sexist because half the crew's female. Sorry about that.
Keep on digging, Andrew. You'll be
I can't see out of the hole anymore. It's a black hole. Very deep one. It's a stellar mass black hole.
Stellar mass black hole. That's right.
At the moment, fast approaching intermediate mass.
Yes. Oh, so that's where they're.
That's where it is, right below me and above me and around me.
Yeah.
Yeah, but let's hope all goes well, and by the time people hear this, they're up and around the planet in an elongated polar orbit and doing some wonderful work. We'll see how it all transpires. Fingers crossed. This is the Space Nuts podcast with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, to our final story, and this one takes us a long, long way out of the solar system. This is a story we've been following, since its exciting flyby of Pluto. It's the New Horizons spacecraft. But since it successfully executed its primary mission, It's been sent off to do a few other things, and one of those things was to examine darkness. This sounds sinister. This sounds like the plot of a horror movie, but it's not. It's a very interesting question, which they think they might have answered.
Yes, that's right. And I think you and I have been talking about New Horizons since its launch 18 years ago, because we used to talk on ABC Radio, didn't we? Before the Space Nuts program came into being. So New Horizons, yes, flyby of Pluto in, was it July, I think, 2015. Flyby of, it used to be called Ultima Thule, and it's now called Arakoth, a small Kuiper Belt object which it flew by probably about 3 or 4 years ago now. It's quite a while ago. In fact, it's longer than that because the flyby was at Christmas and this object looked like a snowman. Until we realized it's actually 2 pancakes joined together rather than 2 balls joined together. Anyway, it is now 7.3 billion kilometers from Earth, a long way away, not as far as our old friend Voyager 1, but still a long way out. The difference, though, between New Horizons and Voyager 1 is that New Horizons has telescopes on board, which, of course, we use to scan Pluto and Charon, Pluto's main moon, and some of the other moons as well. But what they've been able to do, though, is to make measurements of the blackness of the night sky. And I hear you saying, wait a minute, black is black. Well, it's not really. And why should you want to do that from 7.3 billion kilometers away from Earth? The answer is that the solar system is very dusty. And that dust concentrates towards the center of the solar system. So, what we see as meteors, shooting stars, are a measure of the dust that is around us in the Earth's vicinity. That dust scatters light, and we can actually see that in the form of what's called the zodiacal light, which is a glow on the horizon, eastern and western horizon, after sunset and before sunrise. What you're seeing there is light scattered from dust in the inner solar system. It's a pillar of light, quite spectacular. You need a dark sky to see it, though. I've seen it many times from our dark sky sites here in Australia, but I only ever saw it once in the UK, and that was in a particularly dark part of the UK. It was quite interesting, a long time ago as well. Anyway, so the inner solar system is very dusty. That dust scatters light, and that means that if you want to make a measurement of just how intrinsically bright the night sky is, you've got to get away from the inner solar system, and that's where New Horizons is. So what they've done is they've measured what they're calling the cosmic optical background. We talk a lot on Space Nuts about the cosmic microwave background radiation, and this is the background to the night sky in microwaves, which we recognize as having been caused by the Big Bang. We're still seeing the flash of the Big Bang. The cosmic optical background, though, is basically a background haze of light that comes from all the galaxies that have ever existed over the lifetime of the universe.
Wow.
And so this light, is the light of galaxies, turns out to be just the right brightness. I mean, it's been measured. The blackness of the night sky has been measured by New Horizons. The answer they get is exactly what you predict from what we assume is the known number of galaxies in the universe, which is in the region of 2 trillion, if I remember rightly. So really quite a nice piece of work, complemented on by New Horizons principal investigator Alan Stern, an old friend of this program. He says this newly published work is an important contribution to fundamental cosmology, and really something that could only be done with a faraway spacecraft like New Horizons. And it shows that our current extended mission is making important scientific contributions far beyond the original intent of this planetary mission, designed to make the first close spacecraft explorations of Pluto and Kuiper Belt objects. So there you go. It's got the imprimatur of the boss of New Horizons, Alan Stern, And it's a really interesting result that the amount of light in the universe adds up with the number of galaxies that we think exist.
And yet, we shouldn't be surprised, because where else could the light have come from?
Well, that's right, except that one of the scientists who's involved with this work has basically raised that question. Could it come from something we haven't thought of yet? And so the fact that it everything adds up suggests that there isn't anything that we haven't thought of yet. Although you can bet your life that one day we'll be surprised that there's something else going on.
Yeah.
But it's at the moment we think these all add up. The amount of light that's there is exactly what you'd expect from the number of galaxies we assume the universe contains, from galaxy counts, in fact.
I know one source they haven't considered: the laser beams shooting from my wife's eyes when she's angry with me. That's one light source that hasn't been factored in.
You're dead keen on getting into holes today. You're Andrew.
Gosh,
oh dear,
yeah.
I'm not going to go there at all. I think
No. I wish I hadn't either.
Yes. Yeah.
No, but pretty exciting stuff. And New Horizons will continue on its journey, doing more scientific studies, imaging the Kuiper Belt and the outer heliosphere, and making observations from a vantage point that it's unique. It's the only spacecraft in the position to be able to do anything like this. Even James Webb and Hubble can't do the kinds of things that New Horizons is achieving. So we'll be talking about again, I think, Fred.
Yeah, I'm sure we will.
Might take a while because it's still got a long way to go.
Yes, that's right. It's one of the 5 spacecraft leaving the solar system.
Yeah.
But I think it's the best equipped to do to make observations like this.
Indeed. All right. That story available at phys.org, phys.org, if you want to check it all out. And that brings us to the end of the show. Just a reminder too, if you would like to visit our website, you can do that at spacenutspodcast.com or spacenuts.io. You can visit the shop, or you can send us questions. You can get the daily news feed through Astronomy Daily. You can even support us through the Support Space Nuts button. There you are. There's all sorts of things to see and do on our page, spacenutspodcast.com or spacenuts.io. And if you're a social media follower and you watch or listen to us on YouTube, don't forget to hit the subscribe button down below. Thank you as always, Fred. It's been a great pleasure.
Yes, it's been a pleasure for me too. And
that's good.
Long may it continue.
Not many people say that to me.
No.
Thank you, especially today. Thank you, Fred.
Yes. No worries. See you soon.
See ya. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio. And from me, Andrew Dunkley, thanks for your company. We'll catch you soon on another episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.